Okay. Hi friends, in this particular video I am giving you briefly how 8086 is interfacing with various memory devices. So in the previous video I explained introduction of 8086. In that I focused mainly on ROM memory and RAM memory, right? Let us see here how those memories are interfacing to 8086 microprocessor. Okay. See here. See, if you take any memory device, I already mentioned, we have set of address lines. So we have set of address lines called as A0 to AN, sorry, and set of data lines called as O0 to ON. Okay, these lines are data lines and they are bidirectional. Similarly, we have read bar, write bar, read bar, similarly write bar, read bar, and some chip selecting signal like CS, OE bar, all are present. Okay, like that I already explained. And depending on the size of the address lines, corresponding memory will vary. Okay, now let us see how this type of memory is interfacing to 8086 in both minimum mode and maximum mode. Let us see. Okay, let us see this particular diagram. So this is interfacing 8086 with EPROM and RAM as well as IO devices, especially in which mode? Minimum mode. In minimum mode. Okay, let us see in minimum mode. So what is first step for selecting minimum mode? The MN by MX bar signal here. MN by MX bar signal is connected to VCC. Okay, so then automatically our mode is minimum mode. So I already mentioned in minimum mode all control signals are generated by 8086 only. Let us see here. This is your 8086. Okay. Here we have three important pins: clock, ready, and reset. Clock, ready, and reset. These three signals are coming from the external clock generator. So this is your external clock generator. IC number is 8284. So this IC with the help of crystal oscillator, it will generate clock, ready, and reset. See, clock is coming and connected to clock of 8086. Similarly, another is ready, then reset. These three are essential. So in minimum mode operation of 8086, I explained briefly functioning of each one, okay, detailedly, even in the pin diagram also. So these three signals are coming from the external clock generator. Then other is 8086 in minimum mode, there are some set of control signals like M by IO bar, okay, M by IO bar. So this pin will decide whether we are performing a memory operation or IO operation. Then INTA bar. INTA bar is interrupt acknowledgement bar. Then read bar, write bar. Like that, four ready-made signals are available. Right. So now latches. In generally, 8086 requires three latches. Why three latches? Because we have 21 multiplexed lines are there. So what are those? AD0 to AD15 are multiplexed address and data lines. Similarly, A16/S3 to A19/S6. These four also multiplexed lines, and similarly BHE bar/S7 also multiplexed. So put together these three comes like a 21 pins or 21 bits. So these 21 bits are passing through three latches. So latch 1, latch 2, latch 3, three latches. So with the help of three latches, what happens? We get multiplexed address and data lines into pure data lines, and similarly pure address lines. And A16/S3 to A19/S6 also converting like a pure address lines. Like that, how many address lines are appeared? 16 here, 4 here, total 20. So starts from A0 to A19, total 20 address lines are appeared. Okay, here 20 address lines are appeared. So after getting address lines here, BHE bar is separating into S7. Okay, with the help of latch. BHE bar and S7 is a multiplexed. After that, this latch will separate it into BHE bar. So BHE bar is available, 20 address lines are available, and 16 data lines are available. Okay, these 16 data lines are transmitted to trans receiver. So here we are taking two trans receivers, 1, 2. Why 2? Because each trans receiver can transmit only 8 bit, but here we have 16 bit. That's why we need two trans receivers, 1, 2. Okay, next data output will be data lines. So D0 to D15, 16 data lines are available. Okay, so for activating latches, we need ALE signal from the processor, and this ALE is connected to STB. What is STB? Strobing pin. So generally in all the latches we have flip-flops, and all flip-flops are connected to common point called as STB. Whenever STB is connected to ALE and that ALE is equal to 1, then latch will separate multiplex lines into pure address lines during first part of the machine cycle. Remaining part of the machine cycle, these lines act like a pure data lines. Like that, the latch will separate multiplex lines into address lines. Okay. Now OE bar is connected to ground. So OE bar latch is this is now chip selecting signal. Like memory how it is, OE bar also one chip selecting signal. It should be connected to ground. OE bar signal connected to ground, so it will activate. Like that, latches will separate. Coming to transceiver. Transceivers also we have two pins, T and OE bar. T is call it as a transmit. OE bar is output enable bar. This OE bar is connected to DN bar. Then transmitter receiver is enabled, because DN bar is 0 wherever data is available. So during T2 to T4 time we have data. In that time DN bar is enabled. Then OE bar is enabled. Then transmitter is ready to access data. Then DT by R bar is connected to T. T is nothing but 1. If it is a data transmitting, processor transmit data, then it is 1. Processor receiving data, then it is R bar is activating, nothing but by giving 0. Like that, T by OE bar. So anyway, in minimum mode of operation, all these functionings are explained in detail in the old videos. Just verify once. Now coming to memories, I already mentioned memories mainly dividing. For example, if you take EEPROM, it is dividing memory in the form of two banks, even bank and odd banks. Here EEPROM, now this is odd bank. So in that odd bank, we have only odd addresses. For example, memory capacity is 1 megabyte, because I'm on address line. How many address lines I'm taking? 20 address lines. So memory capacity is 1 megabyte. So in that 1 megabyte, starting address is 5 zeros H, ending address is 5FH. So in odd bank, what happens? All odd addresses are present. Nothing but 00001, then 00003, then 00005. Like that, last address is 5F. So then EEPROM even address. In that, all even addresses are present, like 5 zeros H, then 4 zeros 2H, then 4 zeros 4H, then 4 zeros 6H. Like that, last one is F, E. Nothing but 4S, E is the even address, last address. Like that, total memory dividing in the form of even address and odd address. Okay, even RAM memory also call it as a data memory. ROM memory call it as a program memory generally. So this data RAM also dividing in the form of two banks, odd bank and even bank. Odd bank contains only odd addresses, even bank contains only even addresses. IO device. Okay, IO device is also present, but IO device it's not a memory, so it don't have any even and odd. Okay, only one. Like that, we have memories, EEPROM for two, odd and even, RAM also odd and even, then IO. Now other important point is here we are using decoder. So in the coming video, IO interfacing, in that I will explain decoder detailedly. Here you simply remember decoder having set of input pins and set of control pins. We get output. Okay, and that output should be all zeros. So decoder generates, one decoder generates 8 outputs. Okay. Now like that, decoder takes set of input pins and set of control pins, and we get output pins accordingly. Okay, control pins are activating, then only we'll get output. Okay, so there are various control pins are there, G1 bar, G2 bar, G. Okay, similarly various input pins are like present, like A, B, C. Okay, anyway, all details we'll discuss in the coming video detailedly about decoder. So decoder generates, one decoder generates 8 outputs, other decoder also generates 8. Okay, here first decoder outputs I'm calling as Y0 to Y7. Here is O0 to O7. Okay. So transmitter contains 16 data lines. Now coming to ROM memory, EEPROM. EEPROM already I mentioned, it performs only read operation. Here there is two signals I am taking, CS bar, OE bar. CS bar and OE bar. CS bar is chip selecting signal. OE bar is output enable. Okay. So now this OE bar is connected to which one? Read bar. See here, read bar is connected to OE bar. Why I am connecting only read bar? Because reason is it performs only read operation. That's why read bar is connected to OE bar. Okay. Then chip selecting bar is here. I am connecting with one output of decoder with BHE bar. So I already mentioned the BHE bar is very essential for selecting odd memory. For selecting wherever odd memory requirement is there, we should select BHE bar. So BHE bar, that's why I am connecting to this R gate, and assume BHE bar is 0, Y7 is also 0, then output of R is 0. 0 given to CS bar, then it is activating. Like that we are activating ROM, odd memory, EEPROM odd memory. Coming to EEPROM even memory, same. OE bar is connected to read bar. CS bar is connected to one output of decoder. Here I am calling as Y6. Then for selecting even, we need A0. Remember, for selecting odd memory, we need one input of the OR logic is BHE bar. For selecting even memory, we need one input should be A0. So A0 pin is used for selecting even address. Similarly, for selecting odd, we need BHE bar. These two are very important. Concentrate. Now here also EEPROM performs read operation. So address lines. See here we have 20 address lines are there. 20 address lines are mapped address bus here. Here also odd also 20 address lines are there. 20 address lines mapped to address pins. Here also address pins. So 8 data lines are present. So generally EEPROM even bank contains lower data. Odd bank contains higher data. See here lower data means D0 to D7. Higher data is D8 to D15. Generally each memory is holding for 8-bit only. So even address holding lower 8-bit data, odd address holding higher 8-bit data. Okay. So coming to RAM. RAM also having even and odd. For selecting odd memory, here also see here OE bar is connected to read bar. So in addition to ROM memory, in RAM there is a write bar signal because RAM perform read and write. For that, write bar is connected to write bar of processor signal. See, this is write bar signal. Write bar of the processor is connected to write bar signal. Here also odd having higher 8 data lines, even having lower 8 data lines. Okay. For selecting even, we need A0 and output of one decoder. Similarly, for selecting odd, BHE bar is required. Here BHE bar is required for selecting odd. Okay. Like that, you know, this RAM performs both read and write. Similarly, data for selecting IO. So IO also having read, write. Okay, and IO is suitable to perform 16-bit data at a time. That's why D0 to D15. Remember, all data lines are bidirectional. See the arrow? They are bidirectional. But whereas address lines are unidirectional. See here, address lines are all are unidirectional. Address lines are unidirectional. Here also chip selecting signal. Here IO chip selecting signal is activating from the decoder output. Okay, so like that we can analyze how 8086 is interfacing with 1 megabyte of EEPROM and 1 megabyte of RAM and IO devices. Okay, and in minimum mode. So in minimum mode, latches, transceivers and decoders all are controlled by processor only. Coming to same interfacing in maximum mode. Here, now let us see maximum mode. This is maximum mode part. Okay, so in maximum mode also let us see detailedly how we can analyze maximum mode operation. Now coming to first point here, here also we have clock, ready and reset. These three are coming from the external clock generator. So in maximum mode there are three status lines, S0 bar, S1 bar and S2 bar. These three are connected to external bus controller. So external bus controller also having S0 bar, S1 bar and S2 bar. So these three are connected to these three pins of external bus controller. Number is 8 to 88. External bus controller based on these three inputs come from the processor, it generates 8 outputs. One is memory read command bar, memory write command bar, advanced memory write command bar, IO read command bar, IO write command bar and advanced IO write command bar and INTA bar. Like that 8 are coming based on the sequence. If it is 000, then interrupt acknowledgement will occur. Like that it will activate. So processor will decide which operation processor wants to perform. Accordingly, it will send the corresponding bits here. Accordingly, the corresponding command is activating. So now here latches and transceivers both are activated by bus controller based on the command coming from these three. Here also one important point is MN by MX bar is connected to ground. So if it is connected to ground, then our mode is maximum mode because we are activating maximum bar signal, maximum mode. Here we have three latches we are taking. Here also we are taking multiplex address and data lines, multiplex address and status lines and BHE bar / S7. Passing through three latches, we get address lines, 20 address lines, nothing but 1 megabyte and BHE bar also. This is BHE bar. Okay, after getting address lines, the remaining lines are called as data lines here. Data lines are transmitted to two transceivers. We get output is 16-bit data. Okay. Now coming to other important point here is how we are activating latches. Here also latch we have STB and OE bar. OE bar is connected to ground. STB is connected to ALE from the bus controller. Okay. Anyway, in maximum mode operation, I explained completely. Okay, all the blocks. Only thing is additionally we have memories. Okay, that I will focus mainly. Similarly, transceiver also we have two pins T and OE bar. T connected to DT by R bar and OE bar is now connected to DN. In 8086 we have DN bar, but whereas 8288 we have DN. That's why DN is connected to NOT gate. Then output of NOT gate is connected to OE bar. For example, DN is 1, because of NOT output is 0. 0 give it to OE bar, then it will activate. Okay, like that these two are controlled by bus controller. And decoder also, it will take set of inputs as address lines and it will generate outputs. And these outputs are given to memories and IOs for activating. Let us see here memory point of view. Now here also we have 1 megabyte of memory we are taking. So EPROM 1 megabyte having odd address, even also. Similarly, RAM also odd address, even address. So total memory 1 megabyte is dividing in the form of odd address and even address. Okay, here also the connections are same. Only new for memory interfacing, especially in maximum mode, is we have external bus controller and it is communicated to latches and trans receivers. Okay, this part of connection is same as the previous slide. Okay, like that we can interface 8086 with memory devices. Not only 1 megabyte, we go with some other memories also. Like 1 kilobyte means only thing is we should use 10 address lines. Okay, for example 4 kilobytes means we use 12 address lines. Like that here we are connecting only 12 address lines, nothing but A0 to A11 in that case. But here I am connecting all address lines means my memory capacity is 1 megabyte. Like that if you go for any examination, they will ask interfacing 8086 with 4 kilobyte of EPROM and 4 kilobyte of RAM. Then you simply change the number of address lines into equivalent 4 kilobytes. Okay, right. Like that we can interface 8086 with any memory easily. Okay. Now, I think from this video you learned how to interface 8086 with memory devices. Okay. Please kindly share my video to your friends and subscribe my